A piecewise function is a function that has different equations that represent specific intervals of the x values. So here we have an example of a piecewise function on a graph. From negative infinity up to negative 2, we see it has a consistent value. And then at negative 2, we see that that value begins to change, has more of a shape of a parabola. And then when x has a value of positive 2, the function then changes to more of a linear expression. So for different pieces along the x, the function has different expressions that represent those intervals. So we have f of x is equal to 6 if x is less than or equal to negative 2. Negative 2 less than, so that'd be 6. It has a value of x squared if x is between negative 2 and positive 2. And it has the expression of x plus 5 when x is greater than 2. So for each interval, you have different expressions representing the function f of x, but all three of these represent f of x just at different places along the x. The input value of the function will determine which piece of the function will be used to evaluate the value of the function, the input value being the x. So if the x were negative 3, you go to the intervals and you find negative 3, and that would be in this first section here, where it says if x is less than or equal to negative 2. Well, negative 3 is less than negative 2, so the function has a value of 6 when x is negative 3, since this would be the expression representing the function here. If the input value were 0 instead, 0 can be found between negative 2 and positive 2. So x squared would be the expression used to represent the function at 0. And if the input value were a number like 5, then you would use x plus 5 to represent the function. Since 5 is greater than 2, it would fall into this section. So remember, when you're dealing with a piecewise function, the number representing the independent variable is the number you're looking for in the intervals of the x's. This is the x value, so you're trying to find the interval that includes that x value. And then the expression associated with that interval is the expression you use to evaluate the function. Now, one more thing. The expression that includes or equal to includes the value at the limit, while the expression without it does not. So what does that mean? Here at negative 2, where we're going from one interval to a second, the circle that is filled in includes that value. So negative 2 is a part of this first interval. X is less than or equal to. So that circle is filled in. So that means here at this interval, which starts at the same number, negative 2, x cannot be equal to that value, because at negative 2, it's already equal to 6. So that is why this circle is empty. At negative 2, the expression is equal to the one that is filled in, not the one that is empty. On this side, same thing. When we get to 2, we see here x is less than or equal to positive 2. So f of 2 would be evaluated with x squared, since 2 is included in this interval. Whereas x is larger than 2 for the third interval. So 2.1 would be evaluated with this expression. 2.0 is evaluated with this expression. So let's walk through an example together. This is the same piecewise we were just looking at. So f of x is equal to 6 if x is less than or equal to negative 2. F of x is equal to x squared if x is greater than negative 2 or less than or equal to positive 2. And f of x is equal to x plus 5 if x is larger than 2. Question number 1, what is f of negative 2 equal to? Question number 2, what is f of 2 equal to? In question number 3, what is f of 7 equal to? So for this example, I want to go through several points just to show how the expression used to evaluate the function changes based on the input value. So we'll start with -2. So step 1, find the interval that includes the input value, which for the first question is -2. So if we look at the intervals, x is less than or equal to -2. So that's our input value. And here we see the function has a value of 6. So f of -2 is equal to 6, and that would be the final value of the function at this input. The second question was f of 2. So step 1, again, find the interval that includes the input value 2. So here we have -2 is less than x, which is less than or equal to 2. So x can equal 2, and when it does, we use x squared. So we plug in 2 for x, giving us f of 2 is equal to 2 squared. And now that we replace x with 2, we want to evaluate the expression 2 squared, which would be equal to 4. So when the input value changed, we changed the expression that we used to evaluate the function. And again, for the third example, we had 7 as the input. And for the intervals, we see 7 is larger than 2. So we want to use x plus 5 to represent the function f. And now we want to replace each x with 7. So that's how we get f of 7 is equal to 7 plus 5. And now that we've replaced x with 7, we want to evaluate the expression 7 plus 5, which should be equal to 12. So that is how you go about evaluating a piecewise function. Let's now have you try a few practice questions. Given that f of x is equal to x minus 2 if x is less than or equal to -3, and x squared plus 3 if -3 is less than x, which is less than 3, and f of x is equal to -4 if x is greater than or equal to 3. Question number 1, what is f of -5 equal to? Question number 2, what is f of -3 equal to? Question number 3, what is f of 3 equal to? And question number 4, what is f of 5 equal to? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, find the interval that includes the input value -5. So we go to our intervals, and -5 is less than -3. So we want to use the expression x minus 2. So then we want to replace each x with -5, giving us -5 minus 2. And now that we have the expression we need and the number plugged in for the independent variable, the third step is to evaluate the expression. And -5 minus 2 is equal to -7. So the answer to question number 1 is f of -5 is equal to -7. Question number 2, we were asked to find f of -3. So if we go to the intervals, -3 can be found in the first interval since x is less than or equal to -3. Since x is equal to -3, we use the first expression, x minus 2, and replace each x with -3. And now we want to evaluate the expression -3 minus 2, which gives us -5. So the answer to question number 2 is f of -3 is equal to -5. Question number 3, we're asked to evaluate f of 3. So we want to find the interval that includes the input value 3. The second interval is -3 is less than x, which is less than 3. So since x is not equal to 3 in this interval, we use the third interval, since this is where x can be equal to 3. And in this case, the expression is always going to be equal to -4. So when we evaluate the expression, we get f of 3 is equal to -4. So that is the answer to question number 3. Let's now have a look at question number 4. You were asked to evaluate f of 5. So we want to find the interval that includes the input value 5. And that would be x is greater than 3, since 5 is greater than 3. So now when we evaluate the expression here, it's always going to be equal to -4. So we get f of 5 is equal to -4.